All right, let's continue. So we have already covered the struct. So there are actually other constructors in C++. This one, struct and the class, they are actually basically the same. They're interchangeable. Whenever you say, I want to use a struct, basically you can use a class. Right? So there's only one difference is their access. The default access for struct is public, and the default access for class is private. And we will show later what this means. And there's another one, which is called a union. It's actually a slightly tricky thing. So it contains only one of the members. So in struct, when you define all of them, you contain all of them. If you define a union, you only contains one of them. For example, you can define a struct. Right? Inside your struct, you can define some variables. First member is called sample type. The type is a enum. It contains int or double T. It also contains a second member, which is called a value. It is a union. Union means it only contains either int v or double v. And as you can see, their types are different. One of them type is int, another one type is double. So there are some storage issues in here, right? If you are defining int or double, so the size will be the largest one or value, and you can access them through this way, right? You can check. For example, this is a meaningful code. You can check samples dot sample type, right? You can check the type. And if the type is the int tree, right, you can see out this int value. If it's double T, you can output this double value. So this logic is defined by yourself. It's not so important. The important thing is union contains only one of them. It doesn't contain both. Right? And while you are initializing it, you should specify which one does it contain. Right? You can use something like the sample type to specify, okay, for this value, it only contains this int v, or it only contains double v. And as you can see, these ones, they can nest it, right, within each other. Union can be nested within a struct. A struct can be nested in a class, and that class can be stored in a union. Anything, you can nest them together. And if you want to try to access the data inside, just use as many dots as you like, right? Sample dot value dot int v. Int v is another variable or another member. Right. So that's the structures. It's not that important. Unions are it's less used, right? It's typically used in very specific scenarios, especially when you want to save space. But it's not that important in today's computers, right? People are trying to make sure the code are readable. But if you are defining something like this, it's less readable. But anyway, you will see someone writing code in this way. So, yeah, let me skip this one. I don't want to delve into the details. And next, we will define a class, right? So class and the struct are interchangeable. The only difference is public or private. And we say, if we want to define a class, we typically specify an interface first. Right? If you want to define what is a student, right? Student will do something like attend the class, doing homework, and so on. These are called the interface. First, you specify what are the typical operations of the type you want to specify. All right, and this interface can contain all these. We call them member functions. So in our previous one, we only have member variables. Here we have member functions. Right? We can define these functions. That's only meaningful for this class, but not meaningful for the outside. And the interface specified need to be specified in the class definition. We will see later. For example, in our computer product class, we can define something like the make a new product, right? Read in the new product object and compare it to objects and find out which one is better. And also we can print a product, Right? These are the interface we can define for this class. So after getting that, we say every class should have a public interface, right? Typically. Otherwise, why do we define this class, right? If no one can use them. But there are some special cases. We will leave that. And here is what we can do when defining a class. Right? It's very similar to struct. As long as you replace this class keyword with struct, they still can work. They are exactly the same. There'll be no difference between class and struct. And here are some keywords called public and private. Right? Similar to the struct one, we need a semicolon at the end. And we separate them out into private and public. These public are some functions or members that outside can access. It's called the visibility. Right? You can read them, you can call them, you can read them if there's a member defined in here. And this private means these are the members that the outside cannot access. All right, we call them public and private. There's another one called protected, and that one we will leave that to inheritance class. So the first one is called a constructor, right? And we typically, if we try to define a function outside of the class definition. So in our class definition, this one is our class definition, right? We only specify this is our interface. This is the member functions. These are members, right? And these interfaces, we didn't specify what do we mean by read. What do we mean by it's better than, right? One thing we can do is we can put the implementations in here. We are mixing declaration with implementations. It's fine, but a better solution would be put a definition in this way, nice and neat. Then we create another file that will implement all these functions. Right? The first function is called product, and with empty here and no return type, it's called the constructor. This is the constructor. And we always use the class name, right? And two columns to make it clear that we are defining this function for this class. Right? This is the function inside this class, not any function, but a function inside this class. So what does a constructor do is whenever you define a new object, whenever you define a new variable, it will create these, it will call this function. So the constructor has no parameters. It's called when there's no parameter, we call it default constructor. We will have another one later that has some parameters in here. But for this one, it's a default one, and it will be automatically called when you are construct an object like this, right? After you have defined a class product, when you're trying to define a new object called the best product, this is the way we declare or define a new variable, right? This is our new variable. But internally, it is calling this function to create a new one. So when this one is executed, best product, the price is 1, the score is 0. So this is the function that when you define an object like this constructor will be called. And we say every class should have a default constructor. If you forget to write one, they will automatically give you one by the systems. So we will see in next one. Next one is the other member functions, right? Like the read, like the is better than, and the print. These functions are similar to our typical functions. If you look at their signatures, right? So the only difference about the constructor is here, there's no return type. Right? There's no return type because this function calls means you are creating a new object containing this. right? And all the other functions are just the normal functions. Read, have no parameters, return void is better than, get the product as the parameter and returns the boolean, and the print takes no input and has no output. Right? So these are just the simple ones. The read is we sometimes call it a mutator. Mutator means we are trying to modify the object itself. And another tool is print, and it's better than. Sometimes we call them accessor, but it's not that simple as the. Let me see. The difference is here, right? We put a constant here. Means these two functions. When you call these two functions, all these members will not be changed. That's called a constant. This constant. This constant means I will not change the B. This constant means I will not change myself. So that's the slight difference. We put a constant here. And let me move on. So the basic idea about defining a class or defining a struct is that we want to encapsulate, right, the data inside a class, and we don't want the outside to directly access them. If they directly access them, they may do something harmful. And we say only constructors and the member functions can access this private data. We have put all these three members in the private section, right? Like the name, score, price. They are private, so no one outside of your class can access them. They can only access through these functions. Right, here is the way. We have already the best product object. If we call cout best product name, it won't work because it's private. It won't work. It will have some errors. So that's called encapsulation. Right? You want to hide some of the details from the outside. That's very important when you are trying to design your own product. Right? All right. So what's the benefit of encapsulation? First one is enforce the indirect access to the data. Like the if we have a time class, right? Time class contains the minutes, seconds, hours, right? And we put all of them into the private part. They are hidden from the outside, and we have two constructors. We will discuss that later. First one is the default one. Second, the constructor have some parameters, and we have this one can mutate the seconds, right? And all the others are just the accessor. They can get access to the seconds, get access to the minutes, hours, and also the seconds from. So a bad example would be if I put everything inside time to be public, right? You can directly access the hours. This is the time class. This is the object, and we create the new time object. It's 19 hours. This is the minutes, which is 30 seconds, 0. And what we are trying to do is we directly access the hours, right? We class 6 to these hours. If this class allows that, we will have the hours becomes 25, right? It exceeds the 24 format. So that would be bad, right? Because and the other approach would be you ask the programmer, okay, I will tell you my hours shouldn't be greater than 24. You have to follow my instructions. You have to follow my format, right? You are giving your burdens to the other programmers, or you can doing it in your side, right? You can add seconds, right? What does it mean by 6 hours? It means 6 times 60 minutes times 60 seconds. Right? This is the functions you are allowing other people to call. They cannot directly access hours, but you will modify the hours inside these functions for them. So that you can follow these formats, right? Whether it's 24-hour formats or 12-hour formats, it's your decision. Other people cannot change it. That's the beauty of encapsulation. You don't want other people to directly access these members. You will help them modify these members, but you will only give them some of the interface, such as add seconds. You will not give them all the interface, some of the interface that you feel like they should use, right? These are the function calls these programmers should use. So that's the beauty of encapsulation. Any questions on it? No? Right. And we have another mechanism called a friend, but I will not talk about it in here. You can check the mechanism of a friend on your own. Friend means you're allowing other people to modify your private members directly. But that's the beyond of today's lecture. Maybe in the future, you will learn that. And also, encapsulation means you are enabling changes in the implementations without affecting the user of a class, right? When other people, for example, if they want to add 6 to the hours, if initially you are choosing 24-hour format, but somehow you change it to 12-hour format, your user should change your code, right? Initially, they say mod 25. Now they need to change their code mod 12. But instead, if you only allow this kind of interface, right, you're adding 6 hours using this interface, you can change your code from your side. Your user don't have to change anything. In your class definition, in your function definition, you can change it whatever way you like. Right? You can change it to 12 format, 24 format, or vice versa. So it doesn't affect the user. So their code doesn't need to change. So that's the beauty of encapsulation. Right? You are making the user's job easier. You are protect your private information. You are protect your data to follow specific format based on your needs, right? And how can we implement a typical normal member functions? Here is what we can do. Again, other things are exactly the same, except we need to put a class name and column here to specify this read function is the exact read function inside your product. It's not a normal read function. And as you can see, because this function belongs to product, it can directly access its private members, like the price, score, and so on. Right. So your own function can access anything within your class, but outside, they cannot access the private part. They can only access the public part. And a members function can be called similar to the dot, right? When you are trying to access a member of a struct, you can still use a dot, such as the object name dot is function name. This is when you can call this read function. And also, it also means that this read function will modify next product members, right? So when they say price, whose price should they modify? This next product price should be modified, right? When they say score, it means next product dot score. So whichever function calls, whichever object calls this function, every members inside of this function referring to the members of this object. So that's why when we call these functions, we need to put a object here. How about constant? Constant means this function, right? Even though this function belongs to this product class, you cannot modify the data, any of the members of your functions, like the name the price, the score. The only thing you can do is output read. Because of the constant, you cannot say name equals a new name, price equals a new price. You cannot do that because it's a constant function. This constant is the constant for this class. It's different from the constant in the typical function definitions. And when you're referring to a data field, you remember similarly we can do something like this, right? We have covered that. And there's something that's very weird. It's called these implicit parameters. So even though we have nothing in here, right? There's actually one parameter called this. This is a pointer to point to the current object. It is exactly the same as cout name, cout price, or you can say cout this name, this price, this score. This is the object pointed to the current object, and this arrow is the typical operator for pointers. This is something that you don't need to delve deep into this one, but this is the implicit parameters. When can we use it, right? We can use it is something like this one, this function. We are comparing our product, this product, with another product. We are comparing is our current product or this product better than another product, right? Because another product B also has a price, right? And we have a price. You can write it in this way, or you can write this price versus B's price. You can comparing them. But this one, you don't need to use this, but later I have an example. You have to use this. Yeah, it's right. And this parameter is called the explicit parameters, right? This constant product B. So inside your product class definition, right? Even though you haven't finished your class definition, you can start using this, right? It's something you should note. All right, let's go to the constructor. Constructors are actually very complex compared to normal operations, normal functions. So constructors is to initialize all the data fields of an object, right? It has the same name as the class, such as this one. We have a default one, have no arguments, no parameters, and we can give some initialized values. These values are just random value. I put it here. You can choose any starting values. And most of the constructors, if you didn't specify in this way, right, they will initialize the data fields to 0, but not always. You have to keep that in mind. So it's always best practice to make them deterministic, to have some specific values. The compilers will automatically generate a default constructor as long as its members has some default constructors. And we can put something like product, this default constructor equals default. You don't have to implement this function anymore. It's already implemented by the compiler. Right? So yeah, if the members of a class are built-in types or class with default constructors, it will automatically call that functions. We will use some examples. And let's see. All right. Here, let me see if I have some examples in the code. Actually, I don't remember which one I'm referring to. Let's see. Is it dummy? Brand name. Yeah, it's another one. All right, let's look at some examples of defining a class header. So first, forget about this one. For now, we will discuss it later. If not defined, define. So the only thing you need to look at is the way we typically do it is we can define a class. Right? Define a class. The class is called a product, and we can have a public part. Then we have a private part. And the typical style is we will put a public part first. Public part first, then the private part, then this private part, a very small one here. And as you can see, we have default constructors. We have constructors with some parameters, but we will do that later. And we will have some functions, right? The read function, the isBetter function, and the print function. These are all defined in this .h file, and this is how we typically implement a function. Right? We will include this product.h file, and in here we can have some the implementations of these functions. Right? What is read? What is better than? And what is print? Yeah, I don't have the examples for multiple constructors, but anyway, let me come back and see the slides. So constructors, you can also accept some parameters. Right? If you want to define an employee, the first one we'll call the default constructors with no parameters. And the second one we'll call the constructors with parameters. So this is our definition of employee, right? So our employee is a class. It has a public part. It has private part. Private part has name and salary. So our constructors will initialize these two variables or these two members. And it can, the first one, because we don't have any parameter list, this one we'll call the default constructors. And the second one we'll call the second constructors with the parameter list. Right? It will copy Harry Hackers to the name and the 40,000 to the salary. Right? It will copy that, and it will construct these members. But regarding how they implement this one, is not shown in here. We can see how they are shown, how they are implemented. So this one is also called overloading. We haven't defined overloading yet, but here is one example. The same function name, right? The same function name. These two are function names. The same function name, but with different parameter list. Right? You can have a function. Similarly, you can have a function called a set salary, but with different inputs, with different parameter list. It's called overloading. You are having the same function name, but a different parameter list. And the compilers will decide which one to call. And how we can implement this, the second constructor, right? We can have employee, column, employee, which is the constructor for the employee class. It takes two parameters. First one is name, second one is salary. Here we need this pointer, right? Because you use the same name. The name is parameters using the same name as the members, right? You have the member's name, member's salary. Similarly, in this function call, you have the parameters called name and salary. So what you can do is we can use this name, which means the member of your current object. Assign it to this name. This name is this name. This local variable, and similarly, you can assign this salary, the object's salary, to be the same as the salary of your parameter. So this is how you can distinguish if two variables have the same name, right? You cannot simply say name assign name equals to name, salary equals to salary. You cannot do that, but you can do this way. A more efficient way will be something like this. This grammar is very weird when you are first looking at it. So it's like this. You have a first one is the function definition, right? Then parameter list, then the column here. Then you will say construct your member's name with the parameter name, and construct member salary with the input salary, right? And put an empty braces in here, then you are done. You have defined your functions, your constructors. This grammar can only be used for constructors. Okay? And because you have this one, you can say, how about the default constructor? Right? Default constructor, you can do similar things. If you have default values, you can initialize price with 1 and then initialize a score with 0. Right? You can do something like this. This column, and if you look at this one, I believe I also use the grammar, right? If you look at this one, constructors, you can use something called these columns. It's very weird, but this is how C++ defines its constructors. This constructor, default constructor, you want to use 1 to initialize your price and using 0 to initialize your scores. Right. Similarly, in the second one, it contains 3 parameters. Parameter name, price, and score. Use name to initialize your name, using price to initialize your price, and using score to initialize your score. And I put an empty place here. Then you're done with your constructors. It is exactly the same as writing code similar to this, right? So this code, assigning name, salary, are exactly the same as writing this way. It's just more concise and more beautiful. But you will see slightly difference when the members are more complex. Any questions so far? So you need to understand these kind of constructors. All right. It's just a lot of things you need to remember. All right. It's nothing that's very complex. All right. So sometimes, right, when you say a class becomes more complex when these members are also class, right? For the time, arrival time, time of leave time. Your members are another class. How can you construct this kind of object? Right, this would be a problem. Okay, you need to construct this kind of object. They are object, and to construct this object, you will call times constructors. You are calling times constructors. In div, you will call times again calls times constructors. This is how you can do, right? This is one way. You can call this time constructor. It will not be the constructor, but the assignment. Yeah, that's the assignment. But inside here, there's another constructor called, yes. We will talk about that later. So you are actually constructing a new object, then assigning it to your variable, creating a new object, assigning to your members, right? It's basically doing that, but slightly different orders you will see later. Or you can do something else, right? If you use a column, you can construct these normal members like names, salary. You can also construct your time object, right, with some parameters. If there's the for the time, right, it will accept 3 parameters. You can put 3 parameters here. They will call times constructor with these 3 parameters and create a new object for this arrival and for this leave time. So this is the better way to initialize this these constructors. So one thing that's maybe may confuse you is that when you write it in this way, if time don't have a default constructors, it may have some issues when you are trying to initialize in this way. But in this way, it doesn't matter. The time don't have default instructors. This one will call these instructors with parameters. But we will see later. All right, so you can test them. This is then an exercise. All right, let's see. In our main function, we created a new object that belongs to C class. In our C class, we have a member, which is B class. In our B class, we have a member, which is A class. In our A class, it's just empty. It's just nothing, right? But in this constructor, we will call A constructor. Right? So you can nest everything like this one. And this example, I want to show you the order of how these constructors are called. Right? If you want to initialize a C, actually you are initialize a B. In order to initialize a B, actually you are initialize an A. In order to initialize an A, you are calling this function. It will output A constructor. Then we will jump to here, it will output B constructor. Then we will jump to here, it will output C constructor. And all of them, as you can see, right, we are not specifying how A is constructed. It will automatically call A's default constructors. So that's the usage of default constructors. Most of the time, you can let the compiler do the work, right? They will do it automatically. So if you try to understand constructors, there's actually many functions are called when you are calling a constructors. You need to understand how it works. Any questions? This one, right? And the similar things when we are talking about the D constructors, but I will not talk about them in here. But for this one, let's try it. Let's try to see what's the output, right? We can have these, let's call it test. Here's my main function. Here is the definition of class A. Don't have any members. Here is the definition of class B. It has one member called A, right? And we have another class definition is C. It has a B as its members. In our main function, we only do create a new object, which is C type, right? So that's it. It should be, let's see. Yes. Sure. test. Right? This is the order the constructors are called. First, we call A constructor, then we call B constructor, then we call C constructor. What's happening in here is whenever you create a new variable that is from class C, it directly jumps to here, calling line 19, it's calling the default constructors for C. What default constructor C will do, it will first actually create a B function, a B class, or a B member, right? It will initialize its member B. So it's actually calling the B's constructor in here, this B, right? If you're trying to create a C, it will first create a B, then we'll see out. That's the order. It will first create a B, then to see out. And while you are trying to create a B, it's actually going to line 12, right? Calling B's default constructor. So in B's default constructor, what will happen is they are trying to create an A, right? An object A, then to see out. Because A is class A type, so whenever you call A, you are trying to create an object A, it will call this default function A. So the order would be call this function, see out first, then go here, come back to here, see out next, then come back to here, see out next. So this would be the output, A constructor, B constructor, and the C constructor. This is the order of the constructors, right?
So it will run private first, and then it is public.
Not about private or public. It will create this object first, then doing anything inside of this process.
So what if I create a private CC in the class A? It will be the circuit that is.
What do you mean by CC? Is here or
Create a public CC in the class A.
or in class A?
Yes.
Okay. How about that? In that case, we need to define or declare C first. Otherwise, A cannot use C. And we can say, how about you have a private one, which is C, right? Is that what you want?
It is overload.
It's not overloading. Next. This one is called a forward declaration, so that A can use C. Otherwise, because when you read code here, you never see C before, so you need to forward declare it here, but you haven't given the definitions of what is C. But you can declare in the future I will have a C. Yeah, do something like this, but it will be more complex. Let me see. Will it have an infinite loop? C contains B, B contains A contains C. Maybe it will be an infinite loop. Let's try. It's incomplete type. Yeah, we cannot do that. Forward declaration. Class C. Yeah, we cannot do that. It's a too complex one. Yeah, let's try something different, right? All right, let's try something different. How about C contains A, right? What will happen? What if C contains an A and an B? What will be the output? It really depends on whether B is initialized first or A is initialized first, right? So in here, what is actually doing is something like this. In C's constructor, it will create a B, then create an A. In B, it will call this function. In A, it will call this function. Whether this one comes first or this one comes first, the output will be slightly different. if the order is in this way, it should be A constructor, B constructor, C constructor, then A constructor, right? It will be something like this. No. This C constructor will always be the last one, right? We will create A and B first. So it will be A, B, A, C, something like that. Let's see. Yeah, A, B, A, C, right? So this is the way the constructors are called. Oh, wait, it is because I explicitly writing this order. Let me remove this. Let's see what will happen. Still ABAC, which means my guess is correct, right? Any questions on it? Why A is called twice? Why this is the order? Is it clear? So whenever you call a constructor, it will create its members first, then do any other operations.
What is the C colon B? What's the colon?
C column B.
Colon, where is it?
This column?
Yeah.
Okay, this is just the grammar in C++. It means this one is your function, right? This is the body of your function. All of the right-hand side is the body of your function. First one, create a B object, then create an A object, then C object. It's just the grammar. So instead of putting all of them inside your braces, they put it in this way, so that we can skip one more time of the constructions. So let's see the difference between this and that. All right, so you can have this is your function, right? It is similar to this. B equals B. So what will be similar is like this. Inside your C constructor, you will create a B first, then see out these functions. But that's slightly different. You will see, let me try run it. You will see the difference. Right? Compared to the initial version, what's the initial version? Initial version is ABC. It now have ABC. So in here, what actually it's doing is it will create a B first in here. Then in your line 21 is overriding your existing B's with a new one. And then it will continue running. So no matter whether you write it in here or not, it doesn't matter. You can directly delete it. But their functionalities are similar. Right? You are creating a new B. This one is a calling function, calling this constructor functions.
But do you need it? Isn't it? But then with the public version and the private version, is that what's going on? Or
it's not about public or private, it's about the members. Whether you can also make it public, right? You can make everything public. It doesn't matter. It doesn't matter. It's the order doesn't matter. So if you run it, execute it, it is the same, right? It's not about public or private, it's about your members. Remember C++, when they see this object, they need to know how many spaces is needed for the C. It will look at C, okay, they know the space is required the same size as B, right? Then they will create a B for it, so that they can put the data inside of this memory. And when they see this B, they will ask these constructors, right, to initialize this space. So it's more about compiler how they can initialize these variables. In order to initialize this variable, they need to initialize the B variable in this B variable, then you initialize A variable, and so on. It's more about its members. All its members need to be initialized.
But in the presentation, you don't have it. So
Yeah, you can skip that.
you don't need.
It will automatically call. It will automatically call the default function. Yeah, it can automatically call the default functions. And what can be shown more is, what if we have more functions, right? We can have something like the, what if we accept some number x, a constructor with x, right? So what if I have two constructors? In here we have two constructors, because we omit everything in here, so B will will automatically call its default function, and A will automatically call its default functions. We can change that, right? Instead of calling this default function, we can say, how about we create x with a number 10, for example, right? Then this output will be different. As you can see, this A constructor is called with 10, which is calling this function, right? It's not the default one. If you want to try to call this function, you need to give explicit parameters to it so that it can create this A.
Is it overload?
Yes, overloading of the same functions, right? But as you can see, A and the first function and the second constructors, they are not called together. But in another way, this will be different. You're calling explicitly in here, calling the constructors with parameters. What will be the output?
So it will be A10, B.
Yes, correct. So it will be A with a 10, then B, then C, right? As we said, whenever this constructor is created, if there's no column here, it will automatically construct an A with a default functions. Right? Whether you write it here or not write it here, it doesn't matter. All right, it will call these default functions. So what it will actually do is, it will call the first function first, the first default constructor first, and then call the second constructors. So this is the orders. So the grammar, if we summarize, right? Our constructors, what they will do is, they will put a column here. They will put a column here. Then what they will do is initialize all members, right? All members, whether they are public, whether they are private, it doesn't matter. They will initialize in after this column. Then they will run every code in the braces. That's exactly what here will do, right? It will initialize this A, then it will run this code. So no matter you put it in this way or that way, the default A constructor will be called. Yes, question. ABC, that one is the one we have tested with this one, A of A, right? This is something we are testing. If C contains both B and both A, both B and A, it will initialize B first, then initialize A, right? While it's initialized B, it will call, is that the case? I don't remember. Is that the case for this output or the previous output, I don't remember. But anyway, so we are testing something like this. So it will call this constructor, then this constructor, then go in here, then go in here. Okay, this one should be ABAC, right? Yeah, this one should be ABAC. I don't remember what's the version, but we keep changing it. But I don't remember what's the output for that one.
So the only way to avoid calling default
Default
is to confirm this in the column.
Yeah, the only way to avoid the default constructor is putting your constructors in here, right, instead of in here. Then in this way, the default constructor will not be called. It will automatically call the second constructor. Let me delete this one and save it. And wait, oh, okay. I should put that as a comment. Right, as you can see, only a constructor with n is called, right, instead of the default a constructor. Any more questions? It's very important to understand what these constructors are. Yes. Okay, yeah. Last time we have tried, right? Let's try it again. What if I put A here? Typically, the order would be construct B first, then construct A. So what it indeed is doing is B, then A, right? This is what typically would do. So what will be the output? If I run B first, what will be the output? A constructor with 10, then B construct, right? What will be the output of A's default constructor? It will be A constructor, right? Then we will call C constructor. And this is just showing you. Let's see whether it matches the output. Right. First, we will call A constructor with 10, then B construct. It will create the B in C. Then we will call the default constructor for A, which is creating the A in C. Yeah. Yeah, you can change the order, right? If you don't specify the order, it is the default order, and you can always specify the order. Yeah, you can do that. You can try it. Let's try it. Yes, nothing changes. Because that's the memory locations inside your memory, and the compilers will do one by one. They will first look at the first part of your memory locations. Okay, it's B. Then I will do B. Next, I will look at next part of my memory location, which is A. Then I will do A. But you can do it in this way. It doesn't matter. Sometimes it will help the readabilities. If we put some complex group, some of the members together, people will be easier to read. But it doesn't change the order of the compiler, how compilers does. Any more questions? No? Hopefully this exercise will help you understand what is a constructor, right? if we know these constructors, let's continue. Constructor just create or initialize the required memory locations, memory space for an object, right? We could create a new object. It requires to know what will be the space and what will be the values for the initialized version of your object. And another one is called the default parameters. Actually, default parameters can also apply to the normal functions. And we just put it here so that some of the constructors can be simplified. Right? If you have a product that accepts 3 parameters, we can give default ones for the last few of them. For example, we will give the default 1 to score and the 1.0 to price, right? And just these simple constructors, many of the functions can call them. And this is the definition. You put it in your class definition. This is the implementation. So in your implementation, you don't need these default values, right? This is the declare of your function. This is the implementation of your functions. And you don't need the default values in your implementations. You only need to put this default values in your definitions. And how to use it? You can use it in different ways, right? You can call, okay, I will create an object called A. I can create an object called B. I can create an object called C. It's a bad habit to put A, B, C uppercase, right? They should be lowercase because they are objects or variables. So in here, when we call product A with the parameter string A, then it will call this function, right? It will automatically use 1.0 as the price and 1 as the score. So these simple functions, you can use it in 3 different ways because of the default values. If you didn't specify what is price, it will give 1.0 to price. If you didn't give score, it will put 1 to score. And also you can give partial of them, right? For the second one, you can put 2.0 to the price, right? Or you can provide all these necessary parameters, like the C, 2.0, and 2. So in this way, you can simplify the constructors, especially if you have a long list. If you have a long list to initialize your members, you can.
You mentioned that
Mhm.
if you give some members like source, then copy them, you should give the other members for the other version.
Yeah, so I will leave that for you guys to find out by yourself. Yes, so yeah, this one would be a very convenient way to define constructors with a default values, and then you can use it in many different ways, right? All right, so constructors are slightly different from the normal functions. Right? It is called only when an object is created, right? And all the other functions you can call them anytime, but constructors are different. They can only be called when they are created. This way, right? You are trying to call these constructor functions, but it won't work. Right? The homework due is a class time, and in this class time, it defines a default constructor called time with no parameters. You cannot call this function like this, even though this function definition actually inside your object, but you cannot call that. It will have some errors. A simple way would be just to copy it, right? Copy a new one, create a new one, and copy it to it as long as your class supports copy operations. Then next is the we can use another constructor to construct our current one, right? This is our default constructor. This is our constructor with many parameters. We have implemented this the longer version of your constructor. Then in your default constructor, you can directly call these constructor functions. Instead of implementing your own version, giving it some initial values, you can directly call it. It's also possible. And the C++ actually allow you to initialize a class using different ways. Right? First one is the normal way, is the function way. We call a function. We call it's actually calling a constructor functions, right? Calling a function using the parentheses. And another way is using braces, right? To initialize a function. They are actually very similar, but you can think of them as the uniform way in C++, because many of the like the vectors and many other data types, they can initialize using this way. But anyway, you will see someone doing things like this. But I would recommend you guys, as you are beginners, just using the first version, right? Similar to a function calls. And here is how you can access a data field, right? We already know how to do that. For example, raise salary. As you can see, there's no column here. This one is a function defined outside of your employee. Wait, is it defined outside? Yeah, I said it's an error, right? Only member functions can access the is salary. If I don't put employee column, it means this one is outside of your employee. And then if you are trying to access the salary because it's private, you cannot do that unless it's a friend function, but we will define that later. Or we can use these access functions, right? If they provide this kind of functions called get salary, and we can define a new one, right? And then we can call get salary to get the old salary, and then set salary to set a new one. So always use this kind of functions. Do not directly access the private members in your program. It's always using this get set. They are good styles. And we don't have to provide a get function to all these members, right? For example, in our time function, maybe we don't have a set minutes or set hours. We only have something like the add seconds. You don't have to implement all of them. You only implement the functions interfaces that you think are necessary for the users. Right? You don't have to implement them all. It's tedious work. This is implementing a function, right? They can be slightly different from what other people are expecting. Maybe other people are expecting getting minutes, but they are expecting your time class contains the minute members, and they can directly return this member, but it don't have to be that way. You can, in your time class, you can only contain these seconds. You can only contain the seconds members, and you can convert them into what is a minute. You can convert it to them, but the user don't need to know how everything are implemented. What they only need to know is, okay, get minutes will return the minutes. Whether you are keeping the minutes in your members or using the seconds to compute the minutes, it's your job. It's your decision, right? So that's the slightly different things you can do. And if you look at this raise salary, right? And let's see, versus these member functions. If we define a raise salary member functions, it belongs to the employee. And then what we can do is we can directly access this salary because it's a member function, right, of your employee class. This one is not. This one is not. They need to use these getter, setter functions. Yeah, we still have time. So let's see. This one, right? Accessing. So if it's outside of your class, if you want to call it, it has two of these parameters, right? If it's function inside your class, you can directly using your object dot call these functions with the parameters called the percent, right? So these are two different ways. And a member function can invoke another member functions. So for example, if in your print, right, you can call a function like get name, get salary, but you don't actually have to do that. But we said we allow that to be done. So it's quite possible that in a class definition, let me go to some of this code. Do I have that? No, I don't. So it's also possible to do something like this. In your class definitions, you have a lot of public members, but you can also have some of the private members, private member functions, such as you can define what kind of function that like the get the, for example, if I can get ratio, let me just call this some random name, and it will return score divided by price, right? I can have this kind of private functions that no one outside can access, but this is better than they can call this function, right? They can call this function to get your ratio. Of course, you cannot get other people's ratio. You can only get your own ratio, but at least you can call some functions. So it's quite common. You will define many interfaces and you will define many helper functions inside your private part. No one can access. That's only useful for the interfaces defined by your class. All right, I think it's almost this part. So here will be some exercise. You can go back and play with it. Yeah, a matrix, because you never learned that, it's fine. Yeah, I will stop here. So if there will be any questions, you guys can come up here to ask questions. That's it for today.
我不能在主函数里面写 c in n， 然后 c 点什么等于 n。
可以啊，就是你相当于我什么都不用，对吧？
对对，就
我什么都不要，
construct
什么都不要，其实还是有个 constructor，compiler 会自动加一个 constructor 在这里，就是它大概是这样子的。
因为我们定义的是一个 class，
对，你定义的是一个 class， 它会默认分配一段空间给你。这个操作其实就是分配一段空间给你，然后你再在这里面再 cin 到，比如说你有个 a 的 a， 然后你再 cin 到 a 的 n， 但这样是不可以的。因为它是 private， 对对对。
那如果是 public 呢
？public 就可以。对，是的。
只要我们把这个 n 搞成 public 就可以。
对，你就可以这样子说。
好的，谢谢。那这个是什么意思？它这个等于 default，
就是让 compiler 自动分配 default constructor 给你。
就是它自动分配数值吗？
不是，怎么说呢？举个例子哈，像这里，我把其他都删掉了，其他的 b 和 c 都删掉了。这个时候就跟那个一模一样哈。然后我这里比如说想 cout， 我把它变成 public 上，方便读一点。对，我现在可以 cout。这样子是可以的。然后我在这里可以，你可以看它有一些默认的东西在里面。就是你在调用这个函数以后，
所以 default 是一个函数吗？
对，它相当于 C++ 的编译器帮你写了一个函数在里面。它里面做的事情可能就是随机这个 n 的值。
但是你怎么知道 n 就是这个的值？
不是，就是对于一个 class 来说哈，我先把它删掉。就对于一个 class 来说，重要的首先是它的存储量是多少。对于这个 A 来说，它的存储空间可能就是4字节，就是给 int 用的。 给一个放一个数那么大就够了。首先是这个，然后要初始化它的内容。但是对于这个 default 来说，它不做初始化，我只分配空间给你，然后那部分里面原本有什么值，你就是什么值。然后它就会，比如说，这个函数哈，这个函数在那个叫什么机器里面，它其实就是分配一段空间，没了。
所以它这个其实是在给它找一个空间吗？
对，给一个空间能够放下 n 就可以了。
嗯嗯嗯，它这个
嗯，
东西究竟想表达什么？就是它最后等于后面接的是它
就是你这样一句
空
话
间，
这样一句话其实是跟这样一句话是一模一样。compiler 看见这个会干什么事情？分配一段空间给 b，只要够放 double 就可以了，比如说8个字节。对，同样的，compiler 看见这个要干什么？它分配一段空间给 a，只要够 a 大就可以了。a 是多大，取决于这个 class 的 definition。你的 class 怎么定义的？它的大小取决于它有多少个 member。对它来说就一个 member integer，那么它的大小就跟 integer 一样大，所以它就给 a 分配了一段空间。这段空间就代表小 a，然后它里面有个 n，就是这样。这个 constructor 的作用就是这个，就是分配空间，指向把这段地址送给 a，告诉你 OK，你这段就是你的 a。
这个是分配空间的意思，但是我们一般也不这么写，我们好像写就是这样写，
对，
是吗？
是的，就不需要这个
不用
default。
它就是默认的，其实就是地方。
就是如果你是这样子写，你在下面就需要写一个 a 的 a 是什么意思，你就要有个 implementation 在里面，比如说你要有一个初始化的 n，初始化 n 等于比如说10都可以，这样子是可以的。就这样，你要花一点时间去写这几行代码。加 default 是什么意思？我这几行代码不想写了，这几行代码不想写了，让 compiler 决定我这个到底是什么样的行为，这就是 compiler 做的事情。这样就是连它的 implementation 都有了。如果只是这样子，它只是 declare，OK，我有这样的一个函数，但它的函数具体在做什么，它没有讲。这样就是连做什么都讲。
所以说像这种函数，我
嗯
要是要定这个，其实只是一个 declaration，对不对？
对对
然后我如果要写它具体的代码，我可以不在这个 class 里面
对，
写，但是我需要 a 2个冒号这样子，它就是是这个类里面的函数，对吧？
就是通常情况下是这个样子的，就是我们通常情况下未来会有2个文件，一个叫做点 .h 文件，一个叫做点
活
.cpp 文件。
文件的，
对对对，它的文件呢，它里面就是这样的定义：product read，就这样子，然后一堆的说明。
这是不是就是算法？是吗？
不是算法，这个叫 style，就是风格问题。你可以把它写在一个文件里，没问题的。对，只不过说这样子写不好看。然后通常好看的就是 H 文件写这种东西，CPP 文件写这种具体怎么实现。对，
好的。嗯
对对对，
刚刚
哎，是的，谁的？这是谁的插电线？
那是约好了带走的，谁忘了拿了？
先放这吧，我估计他们会回来找的。可以可以。
这2个是有什么区别来着？当时我没有听懂
好，
你
这2个就是
在讲什么。
都可以，就是 C++，
初始化什么？
就初始化一个 A，第2个是初始化一个 B，初始化一个 object A，第2个是初始化一个 object B。
就是它是
一个
针对
class，
这个东西的初始化是吗？
它是针对一个 class，对对，它会调用这一行，没错。2个都会调用这一行，2个一模一样，只不过是 C++ 现在有一个新的写法，是像第2种那样子写的。对，然后你会发现很多很多大家新学编程喜欢用这种。
这是初始化。那如果我要 cin 这些 name price score，
不可以这么做。对于一个 class 来说，你不要直接去 access 它的 member。
那我一开始怎么知道这些东西呢？
就是以参数的形式啊，比如说你先定义一个，你先在外面先 cin 进来，比如说 ABC，或者说 name price score，然后再调用一个 product B，这个 names
直接把它写到里面。
对对对，是的。
你刚刚说有一个就是 private 这些别人是看不到，其实
对
也
看不见
调用不了。
也调用不了。
那如果我从代码的层面上看，我 private 上写什么，不是也是清清楚楚的？你如果不想要泄露数据，它不是还是能从代码里面看得到吗？
不是说，举个例子哈，
嗯
就是以那个 time 为例，
嗯，
我那个 time 在哪来着？
对对对，那个我也没太听懂。
嗯
它这个 time 怎么就可以叫它呢？你怎么知道它是用这个函数呢？
不是，就是如果你是写那个 time 那个函数的人，写那
嗯
个这个，如果你是写 time 这个类的人，
嗯，
你会怎么去定义 time？
怎么去定？
对你比如说，
嗯
当然你可以把那个 hour、second 或者 minutes 放
嗯
在这里，对不对？
嗯
然后让别人去用，
嗯
可以比如说别人叫 get seconds，你就 return seconds；get
嗯
minutes，你可以 return
嗯
minutes。
嗯
但是最主要的一点，别人如果可以随意改变你的内容的话，他们可以这样子做。比如说你有一个 object 叫做 lift off，
嗯
它现在是19:30，
嗯
如果这个是 public，他们可以这样做，他点 hour 加上6，那么它就变成25:30:0，
嗯
对不对？
嗯
我们说这样是不好的行为，因为
嗯
比如说我要不就十二个小时静止，要不就24小时静止，
嗯
它这样随意改了以后，它就不符合比如说 time 的定义了。
嗯
这就是我们为什么不想让别人直接修改我们的内容，我们让他们调用一些函数，比如说叫做增加几秒、增加几个小时，这是我们能够打开的一些，比如说 interface。然后在这个 interface 里面，我们自己去定义，比如说函数应该什么样子。它加6的话，比如说我们要 mod 24啊等等，或者 mod 12，这是我们自己定义的事情。对，所以外面的人是不能够直接修改它的 hours。
所以说这个东西就是相当于一个大的盒子，你什么都看不见里面，然
对，
后这里
这叫
面就是
encapsulation。
class 啊这些很多我们自己定义的东西，然后那个 public 的东西就是 interface
对，
接口，让
你想让别人用的。
然后他真的用了这个的时候，里面我们具体的实现是根据我们的写的东西来
是的，
实现的。
你自己可以定义什么样子都可以，特别是像这个 return 这个 minutes、return seconds。
像这个，它其实就直接的改了我这个
对
hour 的数，所以我不
对对对
想它改。，
是的，我不想让他这么干，我不
嗯
想让他直接访问，所以放到 private 里面。
好。
嗯，
那像这个，它这个有个 time，这是另外一个函数吗？
还是一个 constructor，它其实调用了一个 constructor。
哦，好，那我们先不管这个 constructor，
嗯
它后面这个能这样子写，我怎么知道它这3个参数是 constructor time 这个 constructor 里面的参数？
因为他知道 arrive 它是一个 time 的类型。
我在哪里跟他说了 arrive 是一个 time 的
我
类型？
看一下，这是第几页来着？
25。
25，我们看一下第24页或者第几页。那你不用拉上去，我这拉上去好。这里
嗯哼，
我定义了它们叫 time，
哦，
就是在你的定义，这个是你的实现，
嗯
这是你的 implementation，这是你的 declaration。在
嗯
class declare 的时候，你就告诉他们，
嗯
这个东西就是一个 time 类型的。
嗯
所以你在这样子写的时候，其实在调用这样一个函数。
嗯，所以我们这节课学的主要就是把所有的东西，比如说有个这几个变量或者几个函数统一在这一个 object 一个类里面，我
对对
们可以把它包装起来，
是的
然后再让别人用的时候，我们就用这些 public 的，我们自己实现一些内部的函数，还有
没错
private 的。
没错。
好的。